Science has proved that the human mind has the power to remember what is seen more clearly than what is heard. Moreover, pictures can convey a large amount of information crisply and effectively. As the popular saying goes, a picture speaks 1,000 words. The same saying holds true for numerical data as well. Graphical representation of data helps in understanding the data easily at a glance. Graphical representation of data also helps us in drawing conclusion about the data more conveniently. We have learned how to represent data through pictographs, bar graphs, pie charts, and histograms. We have also seen the representation of frequency polygons. Frequency polygons help us in understanding the shape of the distribution. Recall that frequency polygon is a line graph that can be drawn either by joining the midpoints of the top of the rectangles drawn in a histogram or by plotting the midpoint of class intervals against the frequency of that class. Observe this frequency distribution. The sum of the frequencies of all classes which are lesser than the upper limit of a class is the cumulative frequency of that class. So, a frequency distribution can be converted to cumulative frequency distribution by adding all the frequencies that are prior to a class interval. Can we represent the cumulative frequency distribution too graphically? Yes, we can represent cumulative frequency distribution graphically. The graph of the cumulative frequency distribution is known as the cumulative frequency curve. Let's see how we can draw a cumulative frequency curve for a given data. As there are two types of cumulative frequency distributions, the more than type and the less than type, we shall draw the cumulative frequency curve corresponding to each type of cumulative frequency distribution. Let's consider this data that represents the number of people falling in a particular age group. Let's first write this frequency distribution as the less than type cumulative frequency distribution. Notice that we have taken the upper limit of the class interval and the corresponding cumulative frequency. To represent the cumulative frequency distribution of less than type graphically, we take the upper limit of the class interval on the x-axis and the cumulative frequency on the y-axis by choosing the appropriate scale. Notice that the scales on the x-axis and the y-axis may be different. Now we plot the coordinate points, where the x-coordinate is the upper limit of the class interval and the y-coordinate is the cumulative frequency. The points are 10, 8, 20, 15, 30, 25, 40, 37, 50, 45, and 60, 50. Next, we join the points by a hand-smooth curve as shown here. Since this curve is obtained by the cumulative frequency distribution of less than type, we call it as cumulative frequency curve of less than type or an ogive of less than type. Notice that the shape of the curve is a rising curve. The word ogive is derived from the word ogee. An ogee is a shape in architectural molding known as ogee pattern in the 14th and 15th century Gothic style. This ogive curve is in the shape of an elongated S. Let's now go back to the given data and write the cumulative frequency distribution of more than type as shown here. Notice that here we have taken the lower limit of the class intervals and corresponding cumulative frequency. To represent the cumulative frequency distribution of more than type graphically, we take the x-coordinate as the lower limit of the class interval and the y-coordinate as the cumulative frequency. Now we plot the coordinate points 0, 50, 10, 42, 20, 35, 30, 25, 40, 13, and 55 in the graph sheet. Next, we join the points by a hand-smooth curve as shown here. Since this curve is obtained by the cumulative frequency distribution of more than type, we call it as cumulative frequency curve or ogive of more than type. Notice that the curve is a falling curve. Observe these two curves. These two curves represent the same data. Recall that the median of the group data can be found from the cumulative frequency distribution table, and the ogive is the graphical representation of the cumulative frequency distribution. Is there any relation between the ogives and the median? In other words, is it possible to obtain the median from these ogives of less than and more than types? Yes, the median of the data can be found graphically from the ogives. One way to obtain the median is to find the value of n over 2 on the y-axis, and then identify the corresponding value of the variable on the x-axis by drawing the horizontal and vertical lines. The respective value on the x-axis is the required median. The other way to obtain the median is, if we draw both the ogives of less than and more than types together in a single graph, then they intersect at a point. The corresponding value on the x-axis is the required median for the given data.